So the next person that we're going to see on our 24-hour Maths Magic show, she has many strings to her bow. So she is a mathematician, an author, an educator, and a concert pianist, just to name a few. But you might know her best from her fabulous popular maths books that she has written. So I'd like to welcome to the virtual stage Dr. Eugenia Cheng.
Hello.
Hello. You're with us.
Yes, I saw that headgear was happening, so I decided to wear my favorite hat.
Perfect. Thank you very much. It's such a pleasure to have you here with us on the show. Thank you so much for coming.
Oh, thanks for having me. Thanks for doing it. You've been going for a really long time now.
We have been going for a long time. I've got to be. I've had more sleep than the rest of the team have. I think I've got off lightly somehow in the timetabling. But yeah, it has been 24 hours is a long time, but it's been really great. It's been a really good thing to do. And so obviously, I was saying we've had 23 hours of awesome mathematical magic. So I'm interested to know what you've brought. But perhaps before we do that, it would be good if we could get to know a bit more about you. So maybe if there are some people watching who haven't met your work before, can you tell us a little bit more about yourself?
Yeah, sure. I am an abstract mathematician. So I used to be a kind of normal maths professor. My research is in category theory, which is a very abstract branch of maths. But then I quit and I built myself a portfolio career because I wanted to do more helping of more people and to overcome maths phobia and maths trauma, and to just talk about abstract maths with more people who might be afraid of it, and to make sure that there's some maths outreach being done that isn't all about, oh, this is how useful maths is to solve your real life problems, but about thinking, about how maths helps us think through things. And also, of course, to show that you don't have to look like certain other people out there to be a mathematician, that there's too much in the media and Hollywood mathematicians who are, older white men who are a bit strange maybe and don't have social skills or friends and can't make eye contact. And you don't have to be like that to be a mathematician. And so I wanted to put myself out there as an example of something wearing a hat, I guess, with ears.
Yeah, mathematicians don't have to wear hats. It's not compulsory.
Oh, it's true. I have a friend who's really irritated by the fact that you can't buy hats for children anymore that don't have ears.
Oh, right. I didn't know that was a thing.
I think it is. Anyway, I like the ears. I'm a bit warm though, so I might have to take this off.
Okay, excellent. Thank you very much. So I've read some of your books and seen some of your work on YouTube and that kind of thing. So it's a real pleasure for me to be introducing you. Would you like to start by sharing your trick? What have you brought to show us? I will start.
So what I brought was it's not a trick using numbers or anything like that, because maths isn't just about numbers. Maths is also about relationships and shapes. And so here is a cube. It's one of my favorite Rubik's cubes. It happens to be a Mahjong Rubik's cube. And so my question is, what are the different ways you can slice a cube in half and make different shapes? So the obvious way is you slice it like this and you make a square. And so you might know this problem already, but so the question is, can you slice it in half and make a hexagon? And if you can you build that out of card as a model?
Okay, that's a nice question. I'm not going to. Should I tell you what I think? I don't want to give the game away.
Let everyone have a think.
Let everyone have a think about it. Okay, how could that be done? So you're saying slicing a cube to make a hexagon somehow? Yeah. In half to make a hexagon.
Up to reveal a hexagon.
Okay, so that's the problem. So you're going to give people a bit of time to have a think about that and think about how it could be.
Yeah.
Done. Okay, perfect. So we've got a YouTube chat. It's a live chat going on. Actually, I'll just bring it up and just check if we've had any questions so far. So if people, we've asked people not to put spoilers in the chat. So if you think you know like exactly how this is done, then don't put it in the chat, because it kind of ruins it for everyone else. So let everyone else have a think about it and see if they can come up with a solution to Eugenia's problem. And in the meantime, it'd be good to know more about projects you've been working on recently and what you've kind of had going on this year.
Yeah, thanks. So obviously there's been a pandemic and I hope everyone's doing all right. I feel very lucky that I do many things, and so some of them have not been possible, but writing is still possible. And actually my latest adult book came out this summer, which is X plus Y, a mathematician's manifesto for rethinking gender. But my latest book that I really want to show you is my first children's book, which is this. Molly and the Mathematical Mystery, and it's illustrated gorgeously by Alexandra Artyomovska. And it's about the world of mathematical, amazing, weird things that can happen inside your mind. And so it's not about numbers and equations. It doesn't have that. It's about shapes and structures. And this book has, it's got paper engineering and flaps that you lift up. So there's a,
I feel like I'm getting a sneak preview.
Right, so each page has a message to Molly, who goes wandering off in this mathematical world so each page has quite a deep mathematical concept on it, but you don't have to understand anything advanced. You can just get drawn into the illustrations and to unfolding things. So this is unfolding like this. And so I'm going to show you, this is one of my favorite pages because it has all these infinite really nice doors. The illustrations are absolutely gorgeous. I mean, I gave the ideas for what I wanted, and then the illustrator, I really wanted to show. So this is one of my favorite pages. This has a weaving project. So this is, you can weave these to make different patterns. And so
that's really nice.
It's very beautifully constructed. It took ages to do this, especially because I never met the illustrator, and I and the illustrator and the paper engineer were all in different places. And I can't see you anymore.
I just disappeared actually, just to let people see your book more closely on the. I'm still here.
I see.
I'm still watching.
Okay. And so there's this spinning thing, and I also, here's another page. I'm just going to show you this page that's got some exponential growth in it. So these trees are growing by exponential growth. And I feel like, of course, exponential growth is awfully important. Suddenly it's become something that is very much part of life. And it's one of those things where there's a meme that went around of people going, oh, when are we ever going to use this in real life when they're doing exponentials in class? And like, if only more people understood exponentials now, then something.
Yeah. So it's a word everyone knows now, which is good, but
yeah, exactly. So this ostensibly, it's for the official age range is 7 to 9-year-olds, but I wanted to put in things that I just love, that endlessly fascinate me. And so there isn't really an upper age limit because it's got really, really deep mathematical concepts in it. And at the end, I put some more explanation so that if you are curious, you don't have to understand any math. This is a UK thing. I can say maths.
You can say whichever you like. Yeah.
Nice to say maths. So you don't have to understand anything in advance. But if you're curious, then I put some more explanation about things at the back. And I think that it might seem scary to have a book with deep maths in, because parents might think, oh, I'm not going to be able to explain it. And what I always want to encourage everyone is that it's okay not to understand things. Yeah. Somehow in maths, there's this idea that if you don't understand it, then you're terrible at it. And I think that is often perpetuated by the people who go around boasting about how much they understand it. Yeah. And I think that anyone who thinks they understand it is just wrong, because none of us understands it. Yeah, we can't. It's very deep. There's always more than we can understand. So anyone who claims to understand it completely is just posturing in order to make themselves feel better and to make other people feel stupid. And I want to do the opposite, which is to say none of us understands anything. And if we can embrace not understanding things, then I think that you can get a lot more out of maths. And I understand that fear, because many people have experienced being made to feel bad for being wrong, or made to feel being ashamed. They've been shamed for not understanding something. And so what I try to encourage in this is that the mathematical world is a world that you can explore without particularly seeking any answers, and you can relish not really understanding it. And that's an interesting place to exist. I'm too warm. Because because if you're in a place, if you're confused about something, then you have potential to understand something more and become more intelligent. And I think that's a bit like what Simon was just saying about the wondering at a magic trick and then wanting to work it out. That it's fun feeling confused and baffled, And then the next urge is probably to try and understand it. And then there's potential. I get really excited. It's a sort of interesting balance between a bit of feeling it's like it's a bit painful that you don't understand, but also the potential to then understand something and make progress and become more intelligent. That's a place I love. So I wanted to share what it feels like to be to wander around abstract mathematical worlds. And so and I think it came out really beautifully, I must say. It was funny because on the day it was released in the UK, I hadn't received it yet myself. It took a while to get to me because pandemic, blah, blah, blah. And so all these people were saying, oh, it's amazing. I was like, good, I would like to see it.
That's really funny. It's beautiful. It looks really amazing. I feel like you said it doesn't have an upper age limit realistically. I would like to read it, so I'm glad that there's not an upper age limit.
Right.
Looks lovely. I agree with what you're saying about the kind of the not understanding is obviously it's difficult to get to a point where not understanding is a pleasurable experience. But that, to me, that's the excitement of maths, is when you don't understand something and then you can, how can I think about this? How can I unpick this? How can I reach that understanding? And I feel like we've seen that quite a lot in the last 23, almost slightly more than 23 hours now, of people showing their magic trick. People kind of going, oh, how does that work? Your initial reaction might be, oh, what? No. And then actually once you've got over that initial reaction, then your kind of critical mind starts working and you start thinking, okay, that clearly isn't magic. Let's start from the premise. This clearly isn't magic.
Yeah, and it's interesting because maths can seem like magic when it's presented with too much mystery. And the mystery is wonderful. But then if it's too mysterious, then it can just cause people to go, oh, this is just weird alien stuff landing on my head. I'm going to go and do something else. And so I think it's important to demystify it as well.
That was brilliant. And can you tell us more about the X and Y book, your latest popular maths book for, is it?
Yeah,
not
so
children, but
this one is my thoughts on gender, because obviously I'm asked quite a lot what I think about being a woman in such a male-dominated field, and I think many things. And it's interesting because I used to not want to talk about it at all, because I was trying to hide the fact that I was a woman. I was trying to hide signs of femininity. I wanted to try and make sure I didn't give anyone a chance to stereotype me and say I couldn't do it. And then I decided to try and get in touch with my femininity, and then I discovered that I hated my job, and that seemed to be incompatible with being a career academic. And that's kind of why I quit. And then I came out the other end and I thought, wait, that doesn't make sense. Everything I do is feminine. How can I get in touch with my femininity? I just am a female person. And then I realized that we associate character with gender in a way that's really unhelpful. And I think it's one of the things that contributes to women and other minorities being kept out of mathematics. Yeah. And we make assumptions about what character types are needed for maths. And then some people try and say, oh, well, men are just better at those things, and that's why they're better at maths. And then other people say, oh, well, women need to learn to be like that. And then some people say, oh, well, they can't because they're biologically different. And all of that's completely distracting from the fact that we're actually, I think, we're valuing the wrong things in maths. And we're valuing in normal maths education things like speed and being able to solve problems. And doing things quickly and understanding things quickly, and none of that is actually relevant to higher level mathematics, that competitive aspect of being better than other people. And so I thought about this really hard because I teach art students now at the School of the Art Institute of Chicago, and I used to teach maths students. And when I taught maths students, it was, of course, totally male dominated. And now I teach art students, it's totally non-male dominated.
That's really interesting.
And it is very interesting. And I usually have more trans students than cis white men. Okay. But the cis white men still manage to try and dominate the conversation. And so I thought, it's not just about being a minority, there's some other stuff. And so this is my abstract mathematical approach to things we might be able to do to escape that one-dimensional gendered thinking, which I think would be helpful in the rest of life as well, not just in mathematics, because there are many areas where men dominate, and not necessarily in a productive way, like perhaps, I don't know, maybe politics. Shh, I didn't say that.
It's okay. I'm sure everyone was thinking it anyway. Thank you. That sounds really interesting. I wonder if we've given people enough time to have a think about your hexagon trick. So I'll hand back over to you to to reveal what your secret is?
So I've made one here. And I think, to me, this is one of those things where even if you already know what the answer is, I still think it's really cool. It's like the fact that I love rereading Agatha Christie's, even though I know who did it.
Yeah.
Because it's the way in which it's revealed, although it's the process of the things falling into place that is still interesting, even if you know who did it. And I think that some people, once they know who did, they think the only point is to find out who did it. And that's like thinking that maths is all about getting the right answer. And it's not. Yeah. And so I find this so satisfying. So I've made this little model. Here is a model of a cube. And the point is that if you
I'm going to do this again just so you can.
Okay, so my model has been sitting on the kitchen counter, so it's got a little greasy. But if you suspend it from corner to corner instead of sitting flat on a side, and then slice it horizontally across, then the slice is going to go underneath the top corner, and then there's 3 corners here, and the slice is going to go underneath those 3 and over these 3, because a cube has 8 corners. And so if you slice it in half like that, there's got to be, whatever you do, there's got to be 4 above and 4 below. And so then if you open it out like up, then you get
lovely
2 hexagons. And if you stick them together again the other way, then you make this kind of interesting shape. And if you just rotate it round, then it fits back together to make a cube, which I just find enormously satisfying. And so I stuck a little magnet inside so that I can do this. And it's quite interesting, I think, also figuring out what the net of this is, so what shape it is when you open it up, because there are a lot of different, the net of a shape is the flat thing that you can fold up into a cube. And so a cube has 6 square faces, and there are various configurations of 6 squares that you can fold up into a cube. And then you can imagine how to cut that in half to make these 2 halves. I think that's, and this is something that I did when I was talking to my art students. I love teaching at the Art Institute because my art students think in all sorts of different ways, and they love thinking deeply about things. They're not just trying to get the right answers because they're not interested in situations that have a right answer. And so we just started exploring different ways to cut squares up and make this configuration flat so that you would fold it up into this. And I really enjoy that. It's more about figuring out relationships between different structures rather than calculating an answer to something.
That's really lovely. I love that you put the magnets between them. So it's got a really satisfying, like,
it is very satisfying
when you put them together. That's really lovely. And so you said you were trying to find the net to make the shape. Is that something you can show us, or is?
Well, I could have done if I'd thought about it earlier.
Sorry, no.
Over there somewhere. I've got one somewhere, but I'll leave that with everyone. Everyone can try different ways of doing it.
Homework for the viewer. Something to go.
It's not homework like homework.
No.
Like fun possible activities. Let's call it that.
Okay, that sounds great. Do you have? Because it's Halloween. It's actually Halloween tonight. I kept saying yesterday it's Halloween, and then correcting myself and saying tomorrow. It is Halloween now tonight in the UK. Do you have a treat for us? Because we've seen your trip.
I do have a treat, and you know, really? It happens to relate to the previous. It happens to relate to Simon's treat.
Okay.
Because the treat I've got is a treat that I've made many times, and I never tire of this either. It is, of course, a Battenberg cake.
Really nice.
And the Battenberg cake is a mathematical structure. It is otherwise known as the cyclic group of order 2. It's the Cayley table of the cyclic group of order 2. I used to teach this when I was teaching at the University of Sheffield, and I taught group theory. And I was going through the structure of this. And one day, a student, I give them credit, the student said, "Hey, it's a Battenberg cake." And I was like, "Yes, it is. This thing appears all over the place." And you can make, it's like if you make a multiplication table of 1 and -1, then 1 times 1 is 1, and 1 times -1 is -1. So you get 1 minus 1, and then -1, and then 1, because -1 times -1 is 1. And so I'm completely confused by the mirror image in the Zoom screen. So but it's like, that's the 1 and the 1, and that's the -1 and the -1. And so it's a group structure called a cyclic group, and that's a part of abstract algebra that we teach to undergraduates. But it also comes up if you do addition of odd and even numbers. So an even number plus an even number is even. An even number plus an odd number is odd, and then an odd number plus an odd number is even again. So it makes this pattern. And I also think my favorite Battenberg cake structure is the one about tolerance, because I think that we can sometimes tie ourselves up in knots, wondering whether if we're going to be tolerant people, which I hope we all are, does that mean that we should be tolerant of intolerant people? And I say it's a Battenberg cake, which means that we should be tolerant of tolerant people.
Yep.
And obviously, if we are intolerant of tolerant people, then that's intolerant. But I also think that if we are tolerant of intolerance, then we are contributing to intolerance. And I think that we have to be intolerant of intolerance. And that is what tolerance is. And that means that we can't be neutral about some things. It is not possible to be neutral about racism, for example. We have to be anti-racist, because if we're not anti-racist, then we're contributing to racism. So this is also...
Nice.
It's also the structure that Simon showed at the end with the paternoster. So in his example, he had an A and an O, and it was this shape. And then the words paternoster were across, and that was the jam.
Okay, lovely. Really nice. So in your intolerance, tolerance, just to check, the pink that is in, as I look at it, the bottom right is the, we should be intolerant of intolerance. That's bottom right pink.
That's
perfect.
what I think,
nice.
Yeah.
And so this again is you using your logic and pure mathematics to sort of look at issues in our world in a
to illuminate our thinking about the world, to spot patterns between different situations. Because for me, abstract math is about spotting patterns and finding similarities between different situations, so that you can tap into something that your brain already understands, and then you don't have to redo it all over again. The maths I do has very little calculating answers, and it very rarely comes up with a number as an answer, and we don't have equations, and there's a whole other reason we don't have equations, but it's more about finding structures that illuminate our way of thinking. And since I've been teaching art students, I've been really realizing that I use mathematical thinking. I really do use the discipline of mathematical thinking to help me understand the whole of the world around me, whether I realize it or not. And mostly I didn't, because it just is very second nature to me, because it's what my brain does all the time. But then teaching art students who think extremely differently, I was able to make it precise and make it explicit in order to explain it to them. And then it does two things, because it explains mathematical thinking, and it also helps them understand the world around them. And bringing those two things together is a whole different way of approaching the teaching of maths that I would never have done if I hadn't been teaching art students. If I had just kept teaching maths students in maths universities as a maths person, then I don't think I would have been pushed to that. And that's wonderful, because education should be a two-way thing, right? It shouldn't just be someone standing at the front transplanting knowledge into other people's brains. And I learned so much from my students. I'm really grateful for that.
I would love to keep talking to you for hours, but sadly we've only got a couple of minutes left. And before we do that, I would like to show you via some mystery hands that are going to appear on the camera in a second, a present from Scott Kim. So mathematician that we had on earlier in the show has made you this present. If you have a look and see can you see it in the Zoom call? So, maybe I might stop my video just so it's easier for people at home to see as well.
What am I supposed to be seeing?
So from that angle, I think this looks like your name.
But I can't see anything.
Oh, you
what
can't
am I supposed
see
to be seeing?
In the so in the Zoom call, there should be I've switched my camera off, but there's a second camera called Mystery Hands. Which is
let me go to, I see. Okay, I went to gallery. Oh yes, it does. So
I've given the name of game away.
Can you do that again? I was on speaker view, and so I didn't.
That's fine. So this is saying Eugenia Cheng.
Yeah.
And if you turn it around.
Oh.
How nice.
Wow. Wait, so did he do that for everybody's name?
No, I don't think he did do it for everybody's name. Did he? I wasn't watching.
Because I was going to say, if he managed to do that for everyone's name, that's pretty amazing. That's really cool.
It's very cool. So I'll whiz my camera back on. So Scott was was on our show earlier on in the program, and he did some ambigrams for a few other things. But then he emailed us that one a couple of hours ago saying, "I've done one for Eugenia Cheng."
I would love to receive that by email.
We can do that. We'll forward you the
I would
file.
love that. Oh, thank you very much.
So it's a nice point to end on. It's your present from Scott Kim. I think thank you very much. You've been an amazing guest. Thank you very much for sharing all of your ideas about mathematics and your Battenberg cake, and it's been lovely. So I'm going to say goodbye for now.
Bye.
Thank you very much. Bye bye.